Hello, welcome back to Mrs. Tori's YouTube channel. Today we are going to learn to factor sum and difference of cubes. So when you hear the words cubed, what exponent do you think of? You should think of something to the third power. So there's two formulas, one for difference and one for sum. So first, we talked about difference of squares before. Remember, those were the perfect squares. So we would have like 25x squared minus 4, right? 25 is a perfect square, x squared is a perfect square, and 4 is a perfect square. So we could factor that way. Difference of cubes and sum of cubes are going to look like this. So we're going to have x to the third plus, let's say, 8. 8 is really 2 times 2 times 2, and x to the third is just x times x times x. So this we would use sum of cubes. And then we could also have, how about like x to the 6th plus, let's do minus. We're looking for difference. Minus 64. How do we know that x to the 6th is a perfect cube? You know that because if you can divide 6 by 3, it's a perfect cube. So if your exponent can be divided evenly by 3, it's a perfect cube. So let's look at the formulas and then we'll do a few examples. Let's do difference first. So difference of cubes. So that's going to be when we're given something like a cubed minus b cubed. So two perfect cubes. In order to factor that, we are going to take the cube root of 3, and cube root of a cubed, that would give us a, and the cube root of b cubed would just give us b, right? So first we subtract those, and then our second term is going to be a trinomial. So it's going to be a squared plus a times b plus b squared. Now, this is always going to be the pattern. Since we're taking difference, we are subtracting. So those signs will always be the same. The first sign in your trinomial is going to be the opposite. So since it's difference of cubes, we add first, and this is always addition. So you're always going to end with plus b squared. All right, before we look at sum of cubes, let's just do an example. How about this one? 8a cubed minus 27. So we have this big long formula. Let's figure out what a is and what b is, and then we can just plug it in. So a is going to be the cube root of the first term. So the cube root of a, if you're wondering if an integer is a cube root in your calculator, you can do math, and then I think it's the fourth one. It might be a little different on yours, but I think it should be the same. And then 8, and that pops out a whole number, so it's a perfect cube. So 2, and then to figure out what the cube root of x cubed is, you just divide 3 by 3, and you get 1. So it's just 2x. Then the cube root of 27. If you don't know off the top of your head, you can use your calculator. So math number 4, 27. So that's going to be 3. So b is 3. Now let's just plug it into our equation, or our formula, I should say. So it's going to be a minus b. So 2x minus 3 times a squared. So that's 2x squared. So 2 times 2 is 4, and then x squared. So plus a times b. So 2x times 3 gives us 6x. And then it's always going to be adding b squared. In this case, b squared is 3 squared, which gives us 9. And that is our final answer. All right, let's look at let's look at sum of cubes first, and then we'll just do a few examples of each. So sum of cubes, that's going to be like this one, right? We are adding two perfect cubes. So that's going to look like this. If we have a cubed plus b cubed, and we want to factor it, drop my pencil. We are going to take a plus b times a squared minus ab plus b squared. So let's for a second compare our signs here. So when we're doing sum of cubes, we start by adding a plus b, so that's the same. And then in the trinomial, our first sign is the opposite. And we always end in addition. So if we look at difference of cubes and sum of cubes, it's really the same exact formula. The only thing that changes is here we have addition because it's sum of cubes. Here we have subtraction because it's difference of cubes. And then they're just the opposite here. So those two signs are the only difference between sum and difference of cubes. So you just have to remember the first one is the same, second is opposite. So let's look at an example. X to the third plus 8. Let's first identify our a and our b, and then we'll plug it in. So the cube root of x cubed is just going to give us x. The cube root of 8, we actually already figured out last time, that's going to be 2. So once we know our a and our b, we just plug it into our formula. So we've got a plus b is going to be x plus 2 times a squared, so it's going to be x squared minus a times b, 2x, plus 4. And that's how we factor. Now, you can always multiply to check your answer, right? If we did our box, whoops, one too many boxes here. Those we don't need. We could check it. So x plus 2, x squared minus 2x, positive 4. So let's multiply and make sure that when we multiply these two things, we're just left with x squared plus 8. So we got x cubed. X squared times 2 is 2x squared. Negative 2x times x is negative 2x squared. 4 times x is 4x. Negative 2x times 2 is negative 4x. 2 times 4 gives me 8. So if you notice here, we have positive 2x squared and a negative 2x squared. Those cancel. And we've got negative 4x plus 4x. Those cancel. So check it out. All we're left with is x cubed plus 8. So we know we're right. All right, let's look at one more example, and then we've got one little thing to do. So let's say I give you x to the 7th minus 64x. So first thing you're thinking is, 7 is not divisible by 3. So what the heck are we doing? Well, always look for a GCF first, right? We could factor out an x, and we would get x to the 6 minus 64. Now, this is divisible by 6, and that's a perfect cube. So we can factor. A is going to be x squared, because we take 6 divided by 3, and we get 2. B is going to be the cube root of 64. If you don't know that off the top of your head, put it into your calculator, and you should get 4. Now, we plug it in. So, first, we cannot forget to bring down that GCF. So, we still have an x on the outside. Then we got A minus B, because it's the same sign as here. So, x squared minus 4 times A squared, so that's that's x squared squared. Remember, we multiply, so that would give us x to the 4th. And then plus A times B, so that's 4x squared. And then plus B squared, that's going to give us 16. We are almost done. There's actually one more thing we can do here. Right here, we have x squared minus 4. Hopefully you recognize that as difference of squares. So we can further factor this into x minus 2, x plus 2, and then this term stays exactly as is. So that entire thing is our answer. All right, there is one more thing that we can do with sum and difference of cubes. If I said find all real solutions for x cubed minus 125. So whenever we're finding the solutions, not just factoring, we always need it to be equal to 0. So when we factor, we can use the zero product property. So we see perfect cube. So A is x and B is 5. Well, let's use our formula. So when we factor it, we're going to get A minus B, so that's x minus 5, times A squared minus AB plus B. Sorry, this should be plus there. Sorry, got some announcements here. Okay. So now that we've factored, we said equal to 0. We can use the zero product property. That says x minus 5 equals 0, or x squared plus 5x plus 25 equals 0. Hopefully we can very easily solve this side. It's going to be x equals 5. So that's one of our real solutions. On this side, we have a quadratic, so we have plenty of ways to solve quadratics. We could always use a quadratic formula. That's kind of our go-to. It works for everything, right? But what we could do instead, since we are only looking for real solutions, we can find the discriminant and if it's negative, my solutions are imaginary. I'm only looking for the real solutions. So let's do it. So that's b squared minus 4ac. So 25 is 5 squared minus 4 times a times c. If you don't want to do the math, type it in your calculator. Negative 75. So because our discriminant is negative, that's telling us that whatever solutions we get here are going to be imaginary. So we don't care about them. X equals 5. Now, I shouldn't say we don't care about them. because we're only looking for real solutions here, we're done. All right, that is it for today. See you later.